We're ENVE 5 doing the aeration blower redesign project. We're working with the town of New Milford, which has an oversized wastewater treatment plant that currently consists of 3 aeration blowers. Our goal is to redesign the aeration blower system to make the process more energy and cost efficient.
The aeration blower portion of a wastewater treatment plant works to supply oxygen to wastewater. Microorganisms in dirty influent water use and deplete oxygen when breaking down organic contaminants in the water. The aeration blowers compress and pump oxygen into this wastewater, accounting for 50% or more of the total energy usage at the plant when doing so. Therefore, these aeration processes are a highly beneficial target for fixing an oversized plant.
Our design process began by performing necessary calculations to understand the airflow that the blowers need to supply to the wastewater. We then took these calculated values and contacted blower manufacturers in order to decide on alternative designs for the blowers.
The first step was calculations, which was mainly trying to find the airflow that needs to be supplied by the blowers, and that was calculated generally considering the flow rate, BOD loading, and ammonia loading. That was the data that we were able to gather from the wastewater treatment plant based on their sensors, and from that we were able to calculate first the AOR, which is the actual oxygen required, and then we were able to standardize that through some ratios to the standard oxygen required. Then, through further calculations, we found the SCFM, which is standard cubic feet per minute, which is specifically the airflow coming out of the blowers. And then from that, we were able to find the horsepower based on efficiency. And from that, we could then generalize some expected horsepowers needed when we contacted the blower manufacturers. As you can see in the image to the right, the reason that we're doing all of this is we mainly need to resupply oxygen so that the microbes in the activated sludge can degrade the BOD and the ammonia that comes in through the wastewater.
We calculated that our average air output requirement is 440 standard cubic feet per minute, and our maximum requirement is 860 standard cubic feet per minute. To meet these requirements, we designed a 2 and 3 blower system. The 3 blower system would have 2 smaller blowers that would be designed to meet average condition requirements, and 1 large blower that would be designed for a maximum 860 SCFM air requirement. The 2 blower system would consist of 2 identical blowers that would have turn down capacities to operate efficiently for all air requirement conditions. The redundancy of blowers is required for instances where the main blowers would need maintenance.
To conclude, our aeration redesign project has financial, environmental, and public health benefits. The cost of the initial blower investment will lead to net positive financial savings for the plant from less electricity usage, also benefiting the environment from less energy waste. Effluent water will be discharged to natural waterways, and using correct blowers will ensure oxygen and water is sufficient for aquatic organisms, protecting ecosystems. This clean, uncontaminated water will also serve public health by ensuring no pathogens are present. Thank you to our sponsor, Brian Messner from Wright Pierce, and to our professor, Dr. Agrios. Thanks for watching.